Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have a great webinar on tap today, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it on demand later on. Following the event, we will be sending out an email that includes a link to the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we'll take about 10-15 minutes or so near the end of the presentation and go through the audience questions. Okay, with that, we'll go ahead and kick off today's webinar, which is from 1 to 10 billion traces, getting up to speed with distributed tracing. Our speaker today is Daniel Spoonhauer, who is CTO and co-founder at Lightstep. Spoons, how are you? Thanks for joining me today.
Good, great to be here.
Awesome, awesome. Well, I know you've got a great presentation here, so I'm going to put myself on mute and let you get to it.
Great, thanks. Yes, so I'm Spoons. Thanks everyone for joining. I'm going to talk about getting up to speed with distributed tracing. So at Lightstep, we build and, as it turns out, use a distributed tracing solution. And with that, we enable ourselves and our users to build, deploy, and maintain software with confidence and at scale. And in the course of doing that, we've analyzed billions of traces. And what I'm going to talk about today are just a few of the kinds of things that we've learned along the way. In particular, I kind of want to give a background on what distributed tracing is, talk about how to use it within your application and the kinds of things that you can do with it once you've integrated. But first, I want to ask this question. What does your software look like? Like when you think about it in your mind, what do you see? Or maybe when you're describing it to a coworker or a friend, how do you describe it? Or maybe even if you dream about code, what do your dreams look like? Maybe it's like this, although maybe I'd ask you to zoom out a little bit and not just make the code smaller, but sort of think about the bigger picture. One way to think about that picture is maybe thinking about the overall system behavior or the behavior of particular components. Maybe you start thinking about graphs like these. Or if you're like me, you start thinking about a picture like this. A picture that maybe describes the different components of your application and how they fit together. And I actually think that the way they fit together is really one of the most important parts. In fact, I think we can kind of elide the labels here and just think about the connections between them. And I think that's really important, not just from an aesthetic point of view, but because most performance problems occur at the boundaries between those services or components. And if there's one thing that I would like you to take away from this today is to think about these kinds of problems and where they might occur in your own applications. So why do these problems occur at these service boundaries? Well, one is that network connections can fail, and programming with failure is hard. It doesn't matter if you're using microservices, functions, if you're just using, even with a monolithic application, if you're using some hosted services, those are all points where failures can occur, and those are probably things that you're not thinking about as you're developing the code. If you are, good for you. The other thing is that production is just different, for better or worse. That can be for a number of reasons. Sometimes you just need to have configuration different in production. That could be for security reasons. It could be just the way that your application is deployed. You can have version skew between the services or the components in your application. You might not have tested the latest version of your web app with one of your backends, and you pushed it live, and now you see what happens. And lastly, the scale is just going to be different in production. And for many applications, it's just hard or impossible to really reflect that scale in any other environment. So if you're not thinking about problems in a production environment, if you're not observing a production environment, then you're going to miss things that are happening. And like I said, I think at these boundaries, that's where maybe these problems with a new release are going to become apparent, or maybe it's just a misaligned assumption or expectation between different service owners. So there's an example I'm going to kind of use at a couple of points throughout this presentation, and I just kind of want to give you a background on what it is, and then I'll kind of revisit it a couple of times later on. So this is just a time series showing latency. In this case, it's measuring the time it takes to render a web page. It turns out in our application. And time kind of, as usual, going along from left to right here, and you can sort of see spikes in latency. And in particular, there's one over here on the right that we're going to dig into a bit more, where the page load took more than 17 seconds. And so that's the kind of question I wanted to leave with you. Why was that page load so slow? We'll come back and revisit that and try and dig into what happened there. But first, kind of want to do sort of a distributed tracing 101, just kind of define it and make sure we're all on the same page. So tracing is a diagnostic tool. It's going to reveal how a set of services coordinate to handle individual user requests. Usually it's going to do that by tracing the request as it goes from a mobile app or a browser to backends and maybe all the way to databases. That is, it's going to be an end-to-end trace. And it's going to include probably some other metadata. That could be some additional logs, it could be tags or other annotations, but essentially some other information that, as a developer, is useful in understanding what's happening. And in that, it provides a request-centric view that explains how the application is performing. And I just want to contrast distributed tracing with some other kinds of tracing that you may have heard of or may use. So, of course, we have things like kernel tracing, where we look at how an application interacts with the operating system. There's browser tracing. I'm sure many of you have used some of the great browser tools in Chrome and other browsers to do sort of network tracing or look at how a page is rendered. And you can look at tracing within a single process as well, and there's a lot of great tools for doing those kinds of things. In distributed tracing, we're really looking at the bigger picture, at how the services interact, and I think that's really, like I said, motivated by this idea that the failures are going to occur at those boundaries. To tell you what distributed tracing isn't, so first of all, it's not about your infrastructure. I mean, infrastructure monitoring is great, it's an important thing, but that's not what distributed tracing is going to help you with. And it's not even really time series monitoring or metrics either. It's really thinking about mouse clicks, it's thinking about interactions that your users are having and how those are implemented, how those requests traverse through your application. So this is sort of a picture I drew at the beginning. If I want to put just an example of a trace alongside that, it would look something like this. So just first of all, there are a couple things that map from the left to the right. So what was labeled as a service on the left-hand side here appears as the middle column on the right. But we've got a lot more detail on the right-hand side about what's going on. So first of all, in this trace, you can read it a little bit like a Gantt chart if you haven't seen this sort of thing before, but you're used to doing some project planning. In that, time is going to move from left to right. So the request starts at the left and goes on to the right. And then as we go from top to bottom, that's going from the top of your stack down to the bottom. So here we're handling some sort of reservation request, and you can see as that passes from an iOS app to API proxy to the server to some other backends. And some of the other data that you can see here, you can see the different operations. Some of those might be URL paths, they might be other things. And you can see the duration for each of the individual components of the request. So, of course, there's lots of different trace viewers. I just show a couple of other ones here. All kind of show a similar pattern of how we can display this data. Okay, so I want to go back to this example that I flashed before everyone before. And remember, we wanted to look at this one request that was slow over here on the right-hand side. So if we were to pull up a trace for that one request, we'd see something like this. You can see some really big bars here. This is actually mapping out, as we were developing part of Lightstep itself, how that request went from a browser to a bunch of our different backends. And you can see these really wide bars here, which are essentially as the request passes from one service to the next, almost all of the latency from the initial services at the top was actually due to the services below that until we get down, right down to close to the bottom of what you can see here. And of this more than 17 seconds, almost all of it was actually in this one operation where we were listing out a bunch of histograms that we were reading from storage. Now, it turns out actually reading the histograms took just a tiny fraction of a second, and that actually is not even shown here. It was way off to the right and way down below. But what we learned through this was that it actually wasn't about reading the data. It was actually just finding the list of these histograms that was really the bottleneck in rendering this. So this is sort of an example that let us sort of eliminate a bunch of different options about what's going on. This was a new feature that we're rolling out, and as we put it into our staging environment and through a load test, we started to see different behavior, and it was really through observing these traces that we were able to pinpoint the problem and then correct it by optimizing the way that we did this list. So with that kind of example, I want to kind of go and get a little bit into the terminology of tracing. So first of all, just the trace itself, what do we mean by that? So that really just represents a single end-to-end request. And a trace consists of what we call spans. It can be as few as one, though that's not a terribly interesting trace. But it's not uncommon to see traces that contain hundreds or even thousands of these spans. Now, span, this is just kind of a fancy name for the work done by a single service. It doesn't have to be all the work done by a single service. A service can contribute more than one span to a trace. But it is always the work done by a single service. And you can think of it as sort of like a timed event with some metadata. That is, it has it starts at a given point in time and it ends, and then we have some additional things that go along with it. So the picture I was showing in the previous slide looked something like this. So the colored bar here represents the duration of time. It has a start, it has a finish. There's some duration associated with that. And then, like I said, we can call out the service that this is associated with. And then we also usually talk about an operation. You can think of that as a method name. You can think of it as an endpoint, but something that tells us what the actual work was being done. This terminology actually comes from a paper, a couple of papers, one of them written by one of my co-founders while he was at Google. So again, if you want to see more sort of where this came from and how they thought about it when they're doing this work at Google, you can take a look at this paper. Just Google for Dapper Google, and you can find it. So sounds good. So seems like it could be useful in understanding application behavior. So how do we actually get that? It would be nice if we could get it automatically. Like maybe we can just instrument the runtime in some way. Hook into the bytecode compiler. Now, unfortunately, this is not going to work super well because unlike a single process tool, like maybe talking about a pprof or some other performance tool for a single process, we really need to understand these connections. And one thing we can't do is we can't change the bits as they go out on the wire because we don't really know what's on the other side of this connection when we make a method call across service boundaries. So we really have to leave those bits in place. And that means that we can't actually change at a large scale the way that the entire application is behaving. And I mentioned, bits on the wire. Maybe, we can do some fancy sort of network snooping to figure out what's going on. There's been some work to do this kind of thing, but in practice, it turns out just to be really difficult to be able to match up reliably a request coming into a service with the requests that might go out that are sort of related to the same end-to-end trace. So also pretty tough. And in both of these cases, it's actually important to associate additional application level information with the trace. That's going to be really important in how we debug things. And if we're way down at this low level, we're just not going to be able to do that. I'll give some examples in a couple minutes. Okay, so how are we going to do this? Well, the answer is that we're actually going to get into the code itself, and we're going to add some instrumentation that describes what's going on. So you can think of this a little bit like fancy logging in a way. So I have a really kind of simple service here. I didn't actually even bother using any sort of network call, but just say the work here is that we want to print out hello world or hello someone. And the way that we instrument that is we add a couple of lines to the code. So first of all, we're going to import this tracer through something called open tracing that I'll talk about a bit more in a second. And we do exactly the thing I mentioned a minute ago. We start the timer on this thing, and we make sure that we finish it as well. This will sort of define the beginning and the end. And then in addition, we have an opportunity to say what the operation is that we're measuring here. So like I said, open tracing is sort of the way that I'm showing in this example. Open tracing is a vendor neutral API for adding this kind of instrumentation. So if you're thinking about tracing, I highly recommend that you go check out the open tracing site. There's a lot of examples and some tutorials. And in addition to that, I really think that open tracing is the best way to approach tracing within your application. It lets you as a developer say what matters to you in terms of what kinds of things you want to measure, in terms of what operations you want to call out, without picking a specific tracing solution. So essentially, you can compile this all into your code, and then later on, you can pick where you actually want to send this data and how you want to analyze it, things like that. Now, this might sound like a lot of work. Maybe more work than some of the other tools that you're using today. And there is actually a couple of other nice things about open tracing. If you check out the registry, you can see actually there's a ton of open source projects that have already been instrumented with open tracing. If you have your favorite and it's not there, I'm sure that open tracing would love to help you do that and build that PR for that project. But essentially what this means is that these projects are sort of ready to go. So if you're using one of these projects in your application today, there's probably just a one-line change that you can make to essentially take this instrumentation that's already there and push the data out to some tracing solution. Okay, so just since I mentioned tracing solution, I thought I'd just say just a little bit about how that might work. So, I do this funnel here because, we're going to stick all of these different spans, all this different sort of metadata and things like that are going to go into that funnel. And why do I think about a funnel? Well, generally, we're talking about a lot of data here. So if you think of, you maybe have tens, dozens, maybe hundreds of microservices in your application. Each one of those is generating one or more spans for each request. That's going to end up being a lot of data. And that's going to be expensive to store and manage. And the thing is, most of that data is probably pretty boring. Like most of the time, everything's okay. In fact, at Google, when Google's distributed tracing system was rolled out, and I think to this day, 99.99% of the tracing data is actually discarded. So that is only 0.01% of it is actually used, because that's 0.01% actually represents a pretty big sample. And like I said, most of the data is pretty boring. They are able to pick out the things that were interesting. So what's the point of this funnel? The funnel here is really about figuring out which spans are interesting, which ones are actually parts of the same trace, which other kinds of statistics might we want to aggregate. And this turns out to be hard because not only might these things arrive out of order, that is, they're coming from different places, right? Coming from different services. Some of them might be coming from a mobile app. You've got network delay, you've got buffering. So we don't actually, get them all at the same time for a single trace. So figuring out even what the traces are is tricky. The other thing that's tricky is, like I said, most of them are pretty boring. So finding the ones that are interesting is actually kind of an interesting challenge. And doing that in a way where we're actually telling the whole story of an end-to-end request, because maybe this the authentication runner span was pretty boring by itself, but it turns out to be part of a bigger request which went horribly wrong in some way, and that could provide some important context. So there's a lot of questions that have to be answered if you're going to implement this sort of thing. How do we sample these things? How are we storing them? What sort of analysis are we doing? This is all stuff that a tracer implementation that your solution would need to answer, but hopefully you don't have to care. I could talk about this all day. Maybe we'll do another presentation at some point about this. This stuff is, I think, pretty interesting, but for right now, just assume there's some magic behind the scenes that's going to take care of this for you. Okay, so just to check in so far, what we've done, I've kind of gone over the basics of what distributed tracing is, shown an example of how that can explain some performance problems, what's happening there. And kind of giving you a little sense of what you need to actually do to start using tracing. So what I wanted to do next is kind of talk about how do you get more value and kind of go beyond just those basics. So logging, who would like more logging? I feel like logging is a thing that developers always want more of, and it's sort of a constant battle between the individual developers or teams and the operational or IT teams that are actually maintaining logging systems, or maybe your CTO who's paying for them. And I think, as you get more and more logging, not only is it going to be more expensive, but there's actually just going to be a lot of other stuff that's there that's maybe not that interesting. So, we'd like to log a lot of things. Logging is really important. It can tell us, for within, deep within a service, what decisions are being made, things like that. But actually, finding the right logs can be pretty tricky. So I worked on a service at some point where we were actually sort of an API service that had a bunch of different backends, and each of those backends was actually maintained by a different team. And we actually ended up fielding a lot of the on-call responsibility and ended up doing a lot of the monitoring. And usually what the problem was that one of those other teams had done a new release or had some of their own problems. But the way that we had to do this is that we essentially had to go, whenever we get paged, go grep through some logs and go, for our first service, see, what kinds of problems we might see. That might point us at a second service. We'll go grep through some additional logs. So it was a very manual process of sort of following that path of a request, one service at a time, and taking, like I said, a very sort of manual approach to doing that. So ideally, we'd be able to automate that in some way. And the solution here, maybe not surprisingly, since we're talking about tracing, is to attach those logs to the traces themselves. So what that means specifically is that in addition to starting and finishing these spans just as timed events, also thinking of that span as a sort of sink for sending logs to. What that does is that puts each log entry in context. So here I've sort of got an example, again, an operation that we use internally called query streams. And these are some log entries that we've associated with that we've found useful in our own debugging. You can see that these are pretty verbose. This is just one span, maybe among hundreds, and I've captured a bunch of different data here. Storing this for every time we make this kind of request would get pretty expensive. So what we're actually able to do here is assign some relative value to these log entries based upon whether or not this span is part of a trace that we've decided is something that we should be thinking about. So if this ended up being that 17-second request, great, we've got the logs for it. If it was one of those ones that was faster, sure, we maybe want to get a sample of those, but we don't need to keep all of them. But it also, it sort of avoids this problem of going from one log file to the next, grepping over and over again. We've already got the information organized in a way that allows us to understand which request this log information is associated with. The second kind of metadata I want to talk about is tags. So tags are just key value pairs associated with spans. I guess you could call them labels. Within open tracing, they're usually called tags. And these are just things that enable search among these traces or spans. They enable different kinds of aggregation. And just to give you some examples of these kinds of things, so it might be something like a status code. It might be something as simple as telling you whether or not an error occurred. Might be the version of the software that you're running, or the version of this service anyway. It could be things about your infrastructure. So it could be something about your host, or it could be data center that you're in, something about the network that you're using. But you can actually get even more fine-grained than that. You can start talking about individual customer or user IDs. This would allow you to, for example, search for spans that were associated with a particular customer, or to aggregate them in some interesting way. Or you could go even finer grained than that, and you could look and you could tag by an individual request ID or a session. You can think about how a user might interact over time, but really thinking about like what is information that you might associate with the span that can come back and tell you more about how to put the span in context later. I'll give an example of that in a minute, but first of all, if you've used some other monitoring tools, you might be worried about this, something called Cardinality. This is kind of, I feel like, an overly fancy word for something that's pretty simple. This is just the number of different values that a tag takes on. And at some level, you as a user shouldn't have to worry about this, but maybe you heard that you're supposed to be careful with tags. Using tags might be expensive in terms of how your monitoring tools work, or it might overload them in some way. The good news is most tracing tools actually don't put limits on cardinality. And essentially, the answer here is sort of when we're thinking about a time series or we're thinking about metrics tools, we have to kind of keep track of every different tag value. In fact, every different combination of tag values. And so if you're just talking about maybe hosts or data centers, software versions, we're only really talking about the different combinations on the order of hundreds or maybe thousands. But if we start talking about customers, if we start talking about even sessions or requests, we could be talking about millions or even in many more different combinations. And if we're trying to record something like a metric for each one of those different combinations, that's going to be pretty expensive. But like I said, from a tracing tool point of view, we don't really have to think about all these combinations. We can sort of think about that after the fact. In some ways, tracing tools are a little bit more like logging in a sense. You can think of it, like I mentioned before, as a sort of fancy kind of logging, and the way that a lot of tools will treat the traces themselves is a bit more like logging. Okay, so tags, they're important, and I'll get to that in a minute in an example. But I just kind of wanted to sort of tie it all together. Remember, traces one or more spans. Each span, most importantly, has a start and a finish. That's going to be really important in understanding how performance is being reflected by that span. We want to call out the service and the operation. That's going to be important in understanding how it fits into this bigger picture. And then logs and tags are essentially additional metadata that we can use that'll tell us what is happening in more detail with this request. So I want to go back to my example. This was, remember, this the long 17-second request before. And, we fixed that problem with listing out the histograms. But, we still have got some blips here. And, maybe I should say these might just seem like little blips. But really, from a monitoring and from a performance analysis best practices point of view, you really should be thinking about not just sort of the common or average case, but these long tail infrequent cases. In these cases, we're talking about things that are 99th percentile, so less than 1% of the requests are actually going to be this slow. And I guess you can look at the graph and you can see there aren't that many that are this slow. But these are pretty important for a couple of reasons. One of them is that often these requests will be not uniformly distributed across your customers, especially in a SaaS application, but in many other kinds of applications as well. Your power users, your experts, if you have paying customers, often the customers that are paying you the most are going to be putting the most load on your system. And when they do that, they're often going to be getting, the worst behavior, the worst performance. So looking at this 1%, you might seem like they're not that important, but that might be, more than 1% of your revenue. So thinking about them is important in that sense. The other reason to look at 99th percentile is that this can often be a sort of bellwether for other, or bellwether for the future in terms of the performance that you're going to see tomorrow or next week or next month. As your system scales up over time, what was 99th percentile is going to be more and more common. Okay, so back to the problem here. So we had another slow request. Let's kind of dig in and see what's happening there. So here's a trace for what's happening in that request. And this one's a little bit hard to see from this picture to get it all on the screen kind of here in one screenshot. But if you kind of zoom in and scroll around, what's actually going on here is that there's a whole sequence of requests that are sort of at the bottom of the stack here. You can see the sort of summary of the trace at the top of the screenshot here. Each of these colors represents a different service, and you can see it just goes all the way to the bottom of the stack, and it's just sitting there the whole time. So we're not waiting on network. We're not talking about some complicated interaction. We're just really making a long sequence of calls that hits these leaves. And it turns out what's going on here, one of the spans that's highlighted is this operation called unmarshal. And so, now that we've efficiently listed these histograms or reading them, it wasn't actually reading them from storage that was slow. It was just really pulling the data out of this raw format and putting it into something that we could use to actually do the analysis that was slow. And maybe that's just inherently, like, maybe we should just go optimize the way that unmarshaling works, right? Maybe this is just something that's going to happen everywhere. But if we look at the tags, maybe we can get some other clues about what's going on here. So one of the things is that, maybe this is one of our bigger customers. Maybe their data is actually different than other customers. And if it is, then optimizing the code might not be the right answer, or at least not in the general case. Maybe we should think about the specific use case that this customer is trying to solve. Maybe there's a better way that we can solve that use case. Maybe there's an optimization that we can do that's specific to this bigger customer. It could be that this actually has nothing to do with this particular operation. It could just be that this host is overloaded. I mean, when we're measuring CPU time, we're measuring wall clock time here. So this is actually, as it occurs, it could be that this host is just doing lots of other stuff. So now, I mean, really the question here is it's getting bigger than just this one trace. And really, I think what you need to do is take this kind of bigger view of what's going on in your application and get kind of a 360-degree view of what's happening, not just a single trace, but the whole thing. Because when something's going wrong, it's important to also understand what's going right at the same time so that you can actually compare those two things and understand what's happening. So that means, so tracing is not just an individual request. Of course, it does mean following those requests end to end. But in addition to that, it's also understanding what's different about different kinds of requests. What makes this request unique? What makes it similar to others? So if I can go and look and say, hey, let's compare this customer to other customers. Are they getting similar behavior? Or maybe just compare this against other requests from the same customer. Is this always the slowest part of what this customer is seeing? Likewise, if we're thinking about the host, looking at other operations, other things that are happening on the host, they might be completely different services, completely different requests, different users, but that can still cause contention and still can make this particular operation appear slow. So again, tracing end-to-end and in context. So let's say you've done all these things that we've talked about. You've instrumented some of your code. You found some open source projects that are using open tracing already. You found a tracing tool. You've put the right metadata on there. You've asked some good questions and found some answers. How do you figure out if you're using tracing well, right? How do you figure out if you're doing it right? One way of thinking about it might be about coverage. Like, are you getting a span from every service in your application? Are you getting a span that describes every important operation? What we found is not necessarily, actually. You can actually get a lot of value from tracing, even from only instrumenting maybe 10 or 20% of your application. That can be really important in helping you figure out what to instrument next, what new question should you be asking. And even just by instrumenting part of your application, you can actually go a long way in figuring out where problems occur, which team is responsible, which release was responsible for a problem. I should say, though, that not any 10% or 20% is the same. I really would recommend going towards some key services, going more towards, say, front-end proxy. Like, really, you should be looking at places that are critical to your business, critical to your users' experience. And that's really going to make sure that you get the most leverage out of tracing. Another criteria you might use would be, well, maybe you use tracing to resolve an outage. Again, not necessarily. Like, there's a lot of proactive use cases. In the ones that I was showing before, these are all cases where we were doing or at least most of them were cases we were looking at things in a load test or a staging environment. And you can use tracing not just to kind of get back to baseline if you get woken up at 3 in the morning and you need to fix things, but also to improve that baseline performance. If you're planning out performance work that you're going to be doing over the next week or the next month, using traces to find where the real critical path is really important. This was definitely the case at Google when essentially there was a big MapReduce that was run every week or so that went over a huge portion of the web search traces. And essentially what it would do is it would point to, of all the different kinds of search going into web search, whether it was the web itself or image search, news, personalization, all those different things, this big MapReduce could essentially tell what team was sort of the long tentpole in those queries. Because if a particular team wasn't on the critical path, no amount of optimization was really going to improve things, and it let teams really focus and make sure that their work was had the effect that they wanted it to. I think my success criteria would be the following: that your tool reflects what you already know about your application and reveals something new. Okay. Again, this can happen at any time. It's not just when something is going wrong. This is really to say, back when you're thinking about what your code looks like, that the tools that you're using are actually able to help you learn something about what you're doing, and maybe even help you communicate with others about how your application behaves, how it works. So kind of going back to this picture, the picture I kind of like from the beginning, even if maybe you're just starting off now with microservices or sort of just starting to make that jump, really, it's not the number of services that matters here. It's really about the connections, and those connections are going to grow super linearly with the number of services you have. Those connections are really important in understanding the overall behavior, and they're really important in understanding performance problems and assessing failures. So just to kind of sum up from what we've talked about, so observing end-to-end requests in production is really important. That's what distributed tracing buys you. And those connections between services really give you some important clues and help you understand performance problems. They can tell you where failures occur. They can tell you where you might have misaligned or misunderstood assumptions, where you might have version mismatch. Distributed tracing is going to follow those connections, and it's going to put those individual requests in context. Like I said, it's important to both look at ones that are going badly, like my 17-second request, but also ones that are going all according to plan. And then finally, adding the right metadata, whether that's logging as part of the traces, whether that's adding tags to those spans, will really be critical in finding those root causes. Like I said, that's going to help you understand what's normal and what's not, help you understand when there's a correlation between a failure in a particular customer, a particular host, or whether it's something that's happening all across your system. So with that, I'd love to take questions. Thanks for your attention so far.
All right, great. So we have about 25 minutes or so plenty of time for questions. If you have a question for Spoons, please go ahead and use your GoToWebinar control panel and submit your questions. Let's go ahead and dive right on in. When is the right time to adopt tracing?
Yeah, so I guess I kind of alluded to this a little bit. Thinking about back to my sort of anecdote about grepping through a bunch of logs, I guess my question was sort of maybe a little bit jokingly, how many logs do you want to grep through before you get tired of that? Again, it's sort of really more about the connections between services and thinking about how that part of your service is scaling. But I think maybe a little bit more serious answer is that it's never too early to start thinking about tracing, even if you're not at the point where you have these kinds of problems. Thinking about where the key divisions within the components of your software are, thinking about instrumenting those is really going to be beneficial. And like I said, this is important not just for a microservices environment, but if you're using any sort of third-party services, whether that's hosted storage, whether it's a third-party API to do some sort of analysis or fraud detection, whether it's transaction processing, any of those things, you depend on that third-party service working in order for you to provide your own service. And so it's really important to be able to understand when that's going to be the root cause, and tracing is the kind of solution that's going to help you answer that kind of question.
Okay, all right, great. Next question. Let's see, how does this work with batch transactions? So let's say we are processing a batch of thousands of individual transactions. Can we get a view of the entire batch and of individual transactions?
That's a great question. One of the really fun challenges in tracing is how to visualize some of these larger traces. I guess there's sort of a couple of answers to this question. One part of it is really thinking about each of the individual parts of that batch transaction as themselves sort of individual traces, and then thinking about how we sort of layer on top of that a way to sort of aggregate things. And that could be a place where you use a tag to sort of associate those different things, all those different individual transactions all with the batch. But it's definitely going to, I should say it's going to depend on what sort of tracing solution you're using to actually figure out how that's going to work. I think the good news is in a way that open tracing is really agnostic to the kind of workload that you have, and you'll be able to add open tracing instrumentation sort of regardless of that kind of thing. But yeah, certainly a challenge. A lot of distributed tracing was really developed more for request processing, where we're talking about requests that occur, like in the case of Google, on the order of hundreds of milliseconds. But good question, thanks.
All right, excellent. Next question: Can an open tracing tool help generate logs? And what tools can we use to collect, structure, and visualize tracing using logs?
Yeah, logging is a great question. So yeah, you could actually, I'm trying to think if there's one of these off the top of my head, but it would be pretty straightforward to write an adapter for open tracing that would sort of ignore a bunch of the timing related information and just dump all the logs to, standard out, or to, whatever, Logstash, or whatever your favorite solution is. And that would actually be a great way. I mean, one of the advantages of open tracing is it's not only that it's sort of neutral with respect to the solution, but you actually could use multiple solutions. So you could both send those logs, like I said, to another solution, and you could send them as part of the trace itself. You could do it differently in different environments if that's what you wanted to do. But yeah, I feel like there's a second part of the question that I'm not answering very well.
Let's see. It's what tools can we use to collect, structure, and visualize tracing?
Oh, yeah, that's right. Yeah, so I mean, the Open Tracing website is actually a great resource for different kinds of tools, specifically kind of around tracing. Each of them sort of takes a different approach to how logs can be visualized. But I think, yeah, I think it's a great way to sort of augment what you might think of traditionally as just sort of a set of timing information, and also a way to kind of get visibility across different tools. For example, one thing that we've seen be pretty effective is where you actually provide links from a tracing tool into a logging tool and vice versa. So if you know, for example, that your logging tool is going to be able to find logs based upon a particular tag, tracing tool can just generate links to that tag within the log aggregator. And likewise, if you have the ability to sort of add hyperlinks into your log viewer, that's a way to map back into individual requests. That would have been a great thing for me to have back in this project I was working on, where we were always trying to page other teams.
All right, great. So guys, plenty of time. If you have a question, please go ahead and use your GoToWebinar control panel and submit it. Next question, what is the overhead of this framework? How much compute, storage, network, and what kind needs to be allocated to keep up with the application?
Yeah, great question. Kind of going back to sort of the story at Google, and then I can kind of move forward from there. But at Google, actually found when they did this instrumentation that it wasn't, it didn't impact the latency of requests significantly. So and I believe that this is still true today, that this kind of tracing, it's on 100% of the time in production at Google. The real I guess bottleneck, in a sense, the real sort of overhead was really about storing all this data and collecting it sort of across the wide area network. And that's really what drove Google to make this decision about this 99.9% or I guess 0.01% sampling. It wasn't about the overhead sort of in terms of the CPU time or the latency in the requests themselves. It was really about the managing all of the data. And I think in a lot of ways that's still true today. Because it's actually, this kind of tracing is instrumented as part of the code. It's not something that's sort of, I guess I'd say it's very easy to control the overhead in terms of the inline additional latency in your application. Of course, there's some best practices. I wouldn't start a span within your tightest, fastest nested for loop. That's going to obviously introduce a lot of overhead, but the value of those spans is actually going to be pretty low. For spans that I think can provide a lot of value, where we're talking about things sort of on the order of a network request. Well, if you're making a network request, then saving a few hundred bytes to a buffer on the side is actually going to be quite cheap. So I guess what we see for our customers anyway is that there's a few percent overhead, and that's more in terms of just what I say in terms of throughput instead of latency. Like there's just a little bit of additional work that the that the application needs to do to move this data into a buffer, and then all of the actual sending of the span data is actually done in the background and buffered in a way that sort of stays out of the way of the application itself. I guess then thinking about things like network, thinking about storage, those are interesting questions, and I think, and like I said, this is the part that I think is pretty fun. Of course, sending all of the data for every microservice request over the wide area network would be quite expensive. But it's possible to build solutions. I mean, just for example, Lightstep does this in a way where we have customers that send a span for every microservice request, and they make millions of microservice requests every second, and all of that data gets to Lightstep in a way. We actually have a kind of hybrid on-prem solution that allows us to sort of control the network costs. And then finally, in terms of storage, it really comes down to, you know, what requests are valuable, what's the right kind of aggregation to do. It can be done in ways that are pretty efficient, and where we're really, if we can use the right signals to figure out what traces are actually showing signal, that you can, those can be pretty reasonable costs. I think if you kind of take a pretty naive approach to all these things, like you can sort of build your own tracing tool using a logging tool. So imagine that you just on every log entry you also add in, say, like a trace ID or a correlation ID, some sort of identifier that'll allow you to pick out this particular request. And then you just think of tracing as running queries on your log storage system. That's going to be pretty expensive because now you're storing all this data, most of which you don't need, and then these queries are going to have to be run in a way where you're looking over a huge volume of data. So getting that data in real time, getting it in a way that's actionable, maybe when you really need it, is going to be tough. So yeah, maybe the short answer is naively pretty expensive, but there's some pretty good solutions out there that can do better.
Okay. All right, great. We've got some great questions, so I'm just going to keep going down the path here. Next question, can I use open tracing to trace my Kafka events? Our microservices uses Kafka events to communicate asynchronously. So can I trace this communication?
Yeah, absolutely. I'm trying to remember what the status, there was a PR open to actually essentially leverage Kafka metadata to propagate some information. Really kind of the magic behind open tracing. I mean, what open tracing for, you know, an application developer does is provide this this kind of clean API. But one of the important things that it does under the hood is it defines how sort of context about a request, which could be as simple as sort of a request ID, is propagated from one service to another. And essentially what this open tracing Kafka integration does is it puts that context into the Kafka metadata, and then essentially, you know, the way that we use this thing is that we essentially look at requests that we make to Kafka, and then we pull that metadata out on the other side and use that annotation on the span so that we can kind of connect it across both sides of the queue.
All right, great. Next question. Are there any open source solutions or products that provide distributed tracing from end to end?
Yeah, so like I said, you can definitely find these on open tracing. One of the ones that's getting a lot of momentum these days is a tool called Jaeger. It's an open source tool built by some folks mostly at Uber. And yeah, Jaeger will essentially, I mean, it plugs in with open tracing. It'll collect this data. It'll visualize it. It'll do some analysis for you. There's a couple other smaller ones. Zipkin is an older one that's been around for a bit longer. Excuse me. And there's a couple of other smaller ones that folks have thrown together that are pretty lightweight and maybe more useful in development than in production.
Okay, all right, cool. Let's see, next question. I would assume any tracing tool will add certain lag to the transaction, even if it is small. How deep do you really see normally transactions go on regards to tracing?
Yeah, so like I mentioned a little bit, like that latency impact can really be quite small. I think maybe this is, you know, just to contrast it with where you might be doing not distributed tracing, but an in-process tracing, where you're really, you know, looking at every function call. Of course, that kind of performance measurement can be quite expensive. But if we're really just talking about looking at, say, network requests, we're already talking about, waiting for bytes to travel over the wire. That's probably itself tens, possibly tens of milliseconds. And so the amount of time that it takes to copy a little bit of data is actually quite small. So like I said, at Google, this is on all the time. At our bigger customers, it's on all the time too. It's really pretty minimal, especially when compared to sort of a heavier agent-based approach, which is like where you start to get into these things where you're doing bytecode rewriting and things like that.
Okay, all right, great. Well, that pretty much wraps up the questions that we have gotten in so far. So I do want to thank everybody who did submit questions. There were some great ones there. So guys, thanks so much for submitting those questions. I do want to remind the audience that today's event has been recorded, so if you missed any or all of the event, you will be able to access it on demand. We are going to be sending out an email later today that includes a link to the webinar on demand, so don't fret. The webinar is also going to be on the devops.com website, so you can always check it out there. Just go to the webinar section, look under on demand, and you should see it right there waiting for you. And while you're there, please check out the other webinars that we have, both upcoming and on demand. Hopefully there'll be at least one or two that pique your interest. Spoons, thanks so much for a great presentation. I know I got a lot out of it, and I'm sure the audience did too, especially considering the questions that we did get from them.
Yeah, thanks. My pleasure. Yeah, great questions.
Awesome, awesome. All right, guys. Well, thanks again for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.